Hi everyone, today I'll be talking about problem 25 of the 2003 AMC 12B. 3 points are chosen randomly and independently on a circle. What is the probability that all three pairwise distances between the points are less than the radius of the circle? First, we can draw a diagram to model this out. So we can fix one point arbitrarily, so we don't have to consider the probability for that. And the second point has to be within a radius of this point. And we know that that will form a 60-degree arc with the center. And it can go in either direction. So the second point can be anywhere on 1/3 of the circle. So it has a 1/3 chance. On the other hand, the fourth point depends on the second point's placement. So the furthest the second point could be is 60 degrees away, which means in that case, the third point has to fall within this arc in order to have all the distances be less than the radius. So in the worst case scenario, the third point has 1/6 probability that it can land. However, in the best case scenario for the third point, the first and the second point would overlap, which means that the third point could be anywhere on this 1/3 of the circle. So we know that as the second point moves further away from the first point, the distance that the third point can be will decrease, and you find that the increase of the distance of the second point is proportional to the decrease of the placement of the third point. And so we can take these most extreme values and average them, and we'll get that it's equal to 5/3. Sorry, 1/4. And we multiply that with our first original probability to get 1/12, D, which is correct. Thank you.